Alrighty, now in 7.4, we're going to go beyond square roots and talk about nth roots. So what does nth roots mean? Let's write a few out so we get a feel of what nth roots means. For example, the cube root, or the third root, but we never say third root, we say cube root of 8. What does it mean? It means what number times itself 3 times gives us 8, and you might know that it equals 2. What about the cube root of a negative 8? Normally, we can't take the square root of a negative number without getting an imaginary number, but we can take an odd root of a negative number. Why? Well, think about it. A negative times a negative times a negative 3 times, an odd number of times, gives you a negative number. So you can see that negative 2 would be the answer for that, because it is negative 2 times negative 2 times negative 2 that gives you negative 8. Okay, how about the fourth root of 1, let's say? What number times itself 4 times gives us 1? It's 1. Now let's talk about something. It comes up a lot, and I'm not sure that people are very familiar with it. Let's say you want to take the fourth root of 17 and raise it to the 4th power. What it's saying is, what number times itself 4 times gives me 17? Then I'm going to take that number and raise it to the 4th power. What do you think I'm going to get? Well, it's 17. To help you feel it, how about this? The cube root of 8 cubed. Well, the cube root of 8 is 2. And then if I cube it, I'm going to get 8. So basically, anytime you have a cube root and a 3rd power in a match, they cancel. Now, there's another way of thinking about it. If you think about it this way, it's very easy. 8, the cube root of 8 means 8 to the 1/3 power. Just like square root of 9 means 9 to the 1/2 power. I hope this is not new to you. So the cube root power is the cube root is the same as taking 1/3 power. Then if we cube it, what it means is now we have 8, and when we multiply 3 times 1/3, we get 1. So we get 8 to the 1 power. So that's why we just get 8. The 3 and the 3 cancel, just like here. The 3 and the 3 cancel. Okay, let's move on. So basically, this is what they're saying. If you have a number and raise it to the 5th power and get 32, that number, of course, must have been 2. It's the same as saying, what's the 5th root of 32? What is the number that I multiply to itself 5 times and gets 32? And get 32, it is 2. So let's see. I'm reading this to see what I'm trying to pull out of this definition. Okay, I get that. I kind of already covered all that. So this is called the nth root, because you can put any number there. And this is called the radicand, because it's the thing that's under the radical. This is the index, and this is the radical sign. Okay, you can see that. Principal root. It says, I'm going to read about principal root. I have a feeling it has something to do with this thing that I wrote in the bottom. It says some numbers have more than one real nth root. For example, 64 has 2 square roots, 8 and negative 8. Since 8 squared and negative 8 squared both equal 64, when there's more than one real root and n is even, the non-negative root is called the principal root. So for example, if you see just square root of 25, even though both 5 and negative 5 fit the bill of, well, what number times itself gives me 25, we just usually list the principal root, which is the positive one. Principal is positive. This is different from what we've done before, and let me show you the difference. Before, if we have something like x squared equals 25, when we square root both sides, we always write plus or minus on one of the sides. Okay. Now, if there's a negative sign in front, it just means it's a negative 5. There might be a plus or minus in front, which means that we have a plus or minus 5. Now, this little thing will come into play later. I'm going to come back to it. It's going to be really important. All right, so it's really important now. Okay, so what is going to happen in this lesson? And if I don't give you the shortcut way of remembering it, it's going to be hard to determine when is this needed. Okay. I might do a few problems first and then show you this one little exception. Let's do a few, and I'm not going to do that one. Let's just talk about these two. So I'm going to change the order of these screens so I don't forget to come back to it. Whoa. I'm going to put it down here, and I'm going to put this one down below it, and I'm going to come back to this one. All right, great. So forgive me for that. Okay, remember that when you are multiplying things, which I am doing here, see the little dots? When you're multiplying things under a radical, you are allowed to break them up into separate radicals and think of them separately. So I could think of it, although I wouldn't write this separately because it's a lot of writing, I could think of it as negative square root of 49 times the square root of u to the 8th times the square root of v to the 12th. And then I can do each one separately. So this is negative. The square root of 49 is 7. And this is, what is the square root of u to the 8th? What times itself? 2 times will give me u to the 8th. Well, I hope you know it's u to the 4th. If you took u to the 4th, multiplied it by u to the 4th, you add the exponents, you would get u to the 8th. And a shortcut way of doing that is this. Let me show you. It makes life so easy. If there's no number here in the index, it is implied to be the square root, a 2. You can take the 8 and divide by 2, and that's a quick way to come up with this answer. V to the 12th, what times itself? Gives me v to the 12th. I hope you realize it's v to the 6th. That would be our answer. It's pretty easy. Okay, I think I'm ready. I think I'm ready to show you the exception because it's going to come up. Well, not yet. Okay, wait. I'll wait till the next one. Okay. After number 4, we're taking the 4th root of 16, the 4th root of g to the 16th, and the 4th root of h to the 24th. Again, I'm not going to write it separately all the time. I only did it this one last time, I promise. So what number times itself 4 times gives me 16? Okay, now we might be at the point where we don't know, and we don't feel like trying a bunch of numbers, so we can use our calculator. I'll show you how to do it. I think I have before, but that's okay. What I have to do is hit the number 4 first to show that it's a 4th root. Then I go to math. Then I go down. Well, you don't have to go down to 5, just hit 5. See that little X there that's next to the 5? That's saying that 4, the number I typed in, is that little X. So if you have a newer calculator, it probably shows up nicer, like with the little 4 where it belongs, like I have it written. And then I type in 16. So I get 2. And the reason it's 2 is because 2 times itself 4 times is 16. So this is 2. Now this is g to what power? Will give me g to the 16th if I multiply it to itself 4 times. Well, I hope you said 4. Did you use my shortcut 16 divided by 4? It works. Because look at this, if I multiply it to itself 4 times and I add these exponents, don't I get 16? Yep. Okay, what about this next one? It's going to be h to the 6th. What did I do? Again, the shortcut. 24 divided by 4. And there's our answer. So this times itself 4 times would give me this. That's basically what it was asking me for. Okay, I have a star by this one. It's time to be big boys and girls. All right, we're going to talk about this one exception. And let me go down to here. Okay, let me talk about this. This one is taking the fourth root of something to the fourth power. Now, generally, I cancel the 4 and the 1/4. I cancel them out. I get just y. So why in this problem are they saying it's the absolute value of y? Well, let me show you. I'll show you with the simple number -2. Let me pretend y is -2. Let me see. To identify the principal root. It wants a principal root. Okay. Let's say y was -2. So the fourth root of -2 to the fourth power. Let's talk about that. Isn't that the fourth root of, what's -2 times -2? Times -2 times -2. Isn't it 16? That negative sign disappeared, didn't it? So now it wants to know what times itself 4 times gives me 16. Well, hopefully you know it's 2. Now remember, it could be -2 too, but remember this discussion about principal roots? We just say it's 2, period. We don't say plus or minus, we don't say -2, we just say the positive one, which is 2. Now, since we don't know what y was, the fact that it was a negative value, we ensure that we're answering the positive way by putting absolute value signs around the answer. Now, of course, this is when we're working with variables, because numbers, if I knew the answer was negative, I would just make it positive. So when I'm working with a variable, and I don't know if the number was negative or positive to begin with, I just put absolute value signs around it, again, to ensure that I will get a positive number. Now, this came up periodically in the homework, and we were having a hard time realizing, when do I do positive? When do I do plus or minus? When do I do this or that? And so a student named Phil, I think he's a senior this year, I won't say any last names, but he came up with this. He said, if the answer has an odd exponent, and it was an even root, and an even power, then we need an absolute value sign. So this is his way of remembering it. Even, even, odd. We used to always say even, even, odd. If the root was even and the power was even and the answer had an odd exponent, we're talking about exponents here, we need an absolute value sign on that one variable, whichever variable it is. So even, even, odd, let's use it. Now you might not understand it fully, but when we do some problems like this one, like this one with a star, I put a star by it, we're going to use the even, even, odd check when we're done with it. So instead of trying to rethink the logic of this discussion, where am I? This discussion about cancel the 4s, well, this is just y, no, I need absolute value. Why do I need absolute value again? Instead of going through the whole logic and thinking about numbers and going through scenarios, all you have to do is realize it was an even root, an even power, and the answer had an odd exponent. See that? 4, 4, and 1? If I know that was the case, I need absolute value sign. Okay, let's try this one again, back to back. I'm sorry, I'm getting so lost in my screens. Where is it? It's back before this one. Okay, I'm sorry. Okay, here we go. Again, I'm going to break it up into, just because I don't know if this one seems weird, this is the 6th root of 64 and the 6th root of the quantity 2y plus 1. So the 6th root of 64, I bet it's 2, but let's go to the calculator. Did I turn that off already? Okay. So I hit 6, math, 5, 64, and I get 2. So this is just 2. Oops, I forgot my 18. So what times itself 6 times will give me 2y plus 1 to the 18th? Well, I hope you realize it's 2y plus 1 to the 3rd. How did I do that? Sure enough, I used my shortcut, 18 divided by 6. Now, I started with an even root, an even power, and I got an odd answer as far as powers are concerned. So I need absolute value sign around the term that had the odd exponent. And since it's in parentheses, that one term is like one unit. It is one quantity. So I put absolute value signs around the whole thing. Let's do another one. Here we go. Kind of unrelated. They want us to use a calculator to approximate each of these values to 3 decimal places. So is there a whole number that when you multiply it to itself 4 times gives you 71? Well, the answer is no. So we would have to use our calculator to see what would that number be, and it's going to be a decimal. So I already taught you how to do this. Basically, you had 4 math 571, and the hardest part about the problem is knowing that that's how you type it in, and then now rounding to 3 decimal places. So I get 2.90278, and if I only want 3 decimal places, I take a peek at the next one. If that is a 5 or more, I bump up this one. So I get 903. This is closer to 2.903. I'm looking for, of course, very precise answers. The calculator doesn't lie, and you have to show that you know how to round and read directions. Okay, how about this one? This one's going to be, wait, let me give you a chance to think about it. Go ahead and do 14 and 16 and then play the video again. This is going to be plus or minus 7x squared. Now I have an implied 2, even, so I don't need absolute value signs. This one's going to be negative square root of 81 is 9, a to the 8th, b to the 10th, c to the 6th. Do I need an absolute value sign on any of these? No, because all the exponents are even. I don't need it. Okay, 18, 32, 34. You will not have stars on your test, so make sure you understand when you have to use absolute value signs. Okay, 34 is going to be a really good example to show you something about that. Okay, 18. What are you getting? It should be x plus 15 to the 2nd power. 4 divided by 2 is 2. Here we get y to the 3rd plus 5 raised to the 6th power. If I multiply it to itself 3 times, I will get y cubed plus 5 to the 18th power. Do I need absolute value? Nope, this is an even exponent. Now this one's going to be x squared y to the 1. Oh my gosh, this is an odd exponent. I have even, and now y to the 1, which is an odd. So watch this. The absolute value sign goes only on the y term. Oh my gosh, that's the end. Wow, are you guys lucky. Have a wonderful evening.